0. So this is the cosine value, this is the sine value. So cosine of the angle. Yeah, you have to pay the cost before you get your smoothie. That works too. Good one. So cosine of 90 is 0, sine of 90 is 1, right? So cosine of 90 is 0, sine of 90 is 1. Cosine of 180 is -1, sine of 180 is 0. Does that make sense? So this way, between these two right triangles and that unit circle, you can do any cardinal direction on a 2D plane. Okay. Oh yeah, my mnemonic is that there's always a cost to commit sin, right? Sine and cosine, cosine and sine. So, because people always refer to cost and sin, especially when you're in high school and you don't know what sine and cosine are. So that's how I remembered it when I was learning it in high school. So I've kept it with me the whole time. All right, the last thing that we need to do is we need to take these vectors that are in components and combine them together. And this is just simply Pythagorean theorem. In physics, I believe they call it the law of superposition when you're taking vectors that are in component form, x and y directions, and adding them up and to find the resultant vector. But still, realistically, it's just Pythagorean theorem, right? And what does Pythagorean theorem tell us? The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse, right? So in this case of our graph here with the velocity, so vx squared plus vy squared is equal to v squared. Okay? So why is this important, right? So remember that graphical one earlier that we did where we just graphed it? Well, now we can take a look at each of the x components. We can break it up. Here's your ax. Here's your bx. Here's your ay. Here's your by. And what you end up getting to find cy is simply ay plus by. And then cx is simply ax plus bx. So by breaking those vectors down into a horizontal and a vertical direction, we can add them together to find the resultant. And to find c, we simply do cx squared plus cy squared is equal to c squared, and then we square root both sides, right? So by looking at that, we can come back and see how useful everything on this page is. So I can't stress it enough. You need to know and remember your helpful right triangles. It's going to help you remember your Pythagorean theorem, and you need to remember your unit circle. Notice I have not talked about displacement, velocity, or acceleration. This is what I consider basic concepts. And understanding these concepts is what most physics professors don't go over. They assume you know it, right? From geometry, trigonometry, all stuff that you did in high school. And even algebra, right? Your Pythagorean theorem, that's when you learned it in algebra. Algebra 1. But all of those concepts that we looked here on this page help us do our addition of vectors when you have multiple vectors adding with each other. And you can do it algebraically instead of just looking at it and doing it graphically. Okay? And this is where that lack of continuity comes in, right? Because you guys are so used to just adding numbers, which is all scalars. You're not used to adding vectors, which have components that you need to add separately and then recombine them using Pythagorean theorem, or what they call the law of superposition for vectors. Okay, just a fancy name for Pythagorean theorem. Any questions so far? Correct. That's right, Melody. Pretty easy, right? So if you take each individual vector, break them down into components, you can add all the x's together, and you can find the sum of all those vectors added up together. And you can add all their y's together. You can technically do this for 3D too. It's just an extra step, right? You'd have to do all their z's together too, right? If you had to do it for multivariate or engineering calculus, but you're not going to be dealing with that for the MCAT. But yes, that is correct, Melody. Any other questions? Awesome. If I'm moving too fast, feel free to stop me. Okay. So let's go over some vocabulary. Displacement. Displacement is location relative to a reference point. The units for displacement is in meters. It's usually denoted as x vector, y vector, or s vector for arc length when you have circular motion. The scalar corollary to displacement is distance. So displacement is your vector term, distance is your scalar term. And we'll see how that comes out in a little bit when we talk about the types of questions they ask you. And distance is simply how far two things are from each other. Same units, just x, y, and s, no vector notation. Next term we need to know is velocity. Velocity is simply the change in displacement over the change in time. Units are in meters per second, denoted as v vector notation. The scalar corollary to velocity is speed. Speed is simply a change in distance over the change in time. Same units, v, no vector notation. And last but not least, in terms of vocabulary, acceleration. We define acceleration as the change in velocity over the change in time. The units are in meters per second, otherwise known as meters per second squared. And it's denoted as a vector notation. Luckily for us here on Earth, we have a constant and uniform acceleration. What is it? Yes, gravity. It's 9.81. It's pointing down. For most calculation purposes, you're going to be approximating it with 10, and they will give you exact answers. So just expect your answer to be slightly less than what you use the 10 approximation and what you get when you're doing your calculations, okay, for your MCAT. So this is the vocabulary and all the terms that we need to know. So we're finally getting into translational motion, okay? Now we're going to get to the meat of it. There's only 4 equations that you need to know today, okay? Out of everything, there's only 4, okay? This is called simple kinematic equations. These equations are used at constant or uniform acceleration. Luckily for us, we have gravity, okay? So first kinematic equation, change in displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared, right? And we use this equation when we're not given a final velocity, VF. Second equation, change in displacement is equal to 1/2 V initial plus V final times time. And we use this equation when we're not given an acceleration. 3, V final is equal to V initial plus acceleration times time. And we use this equation when we're not given a change in displacement. And last but not least, final velocity squared is equal to initial velocity squared plus 2 times the acceleration times the change in displacement. And we use this equation when we're not given time. So these are the 4 equations that you're going to be doing today with regards to translational motion and kinematics. So when we talk about 1D linear and then 2D collinear motion, it's still based on these 4 equations. So every time we talk about projectile motion, which is 2D collinear motion, we're going to be using these 4 equations. Yes, so Michaela, I use S because it could be X or Y, and it could also be arc length for circular arc of travel. So I use S because you can substitute X or Y in for it as well. So you can see in your book, they wrote it for an X direction and then rewrote it again for a Y direction. It's just still the same set of equations, okay? But yeah, you have it both in terms of X, delta X is equal to V naught T plus 1/2 AT squared, or delta Y is equal to V naught T plus 1/2 AT squared. And we're going to be using it in that sense when we talk about it in terms of the cardinal directions, the up and down and the right and left, right, for our 2D Cartesian coordinates that we're looking at later, okay? But yes, that's how they're generally written. I just like to write it as S because it's inclusive of arc length, which is still a displacement. It just happens to be in a displacement in a circular path. We'll talk more about circular paths and stuff next time when we talk about forces and rotational kinematics, okay? So let's take a look. There's 2 assumptions that the MCAT uses. Sometimes they tell you, sometimes they don't. So the first one, they generally tell you that you're within a vacuum environment. So they'll say neglect air drag, air resistance. So that's just like basically saying you're in a vacuum. We have no atmospheric pressure because there's no gas molecules around us, okay? It's equivalent of being in space. The second assumption they do not always tell you when you're doing these kinematic problems is that all masses are point masses. So whether you have a tank, a car, a video game, a book, a laptop, whatever you have that they're giving you as an object that you're throwing or moving, all the mass is centered at the center of that object. Okay? So, because if you think about it, masses are distributed like across an object, right? So if you look at your leg, your upper leg is much more massive than your lower leg, right? Because there's 4 muscles in there as opposed to the calf muscle only in the lower leg. So way more massive, right? Same thing with your torso. Your legs are much bigger in proportion in terms of mass than your arms. So that's why your center of gravity is a little bit below like your stomach. Sorry, resistance, air resistance. Apologies. Neglect air drag, comma, air resistance. So they'll tell you that we're neglecting that there's air in the surrounding environment, which means it's in a vacuum. It's another way of saying vacuum environment. Okay. Correct. Whether the object is this, we're just taking that all the mass at that point, and then we'll draw all our vectors from that point in terms of the weight of an object. Does that make sense, Michaela? Sorry, it's easier if I just draw it out. Because I guess there's still confusion. Cool. Any other questions? So, can't stress this enough. These 4 equations, you need to know just as well like you do your back of your hand. So what I end up doing, and I end up telling students to do, a lot of the tests, especially since it's always speed and you're trying to get things done quickly. On one side of my flashcards, if you're a flashcards person, I would write the question, like an MCAT style question that you get from your workbooks. And the other side, you'll get the equation. So I can't stress that enough, because the faster you recognize what to use, the easier it will be to do your physics type problems. Okay. Any other questions? So please remember, I do not have any cool mnemonics to remember the 4 equations. If you are a calculus person, the derivative of equation 1 is equation 3. Equation 4 is an energy conservation equation, which I'll show you again when we get to work and energy, and how that is equation 4 and how that came about from conservation of energy. And equation 2 is just the average velocity times time, right? V initial plus V final divided by 2 times t. But the real one you really need to remember is equation 1, because you end up using it the most. I think 1, 3, and 4 are the ones you use the most if you actually go through and look at the workbook and what's presented out there. Okay, so let's get you guys thinking about sorry, Stephanie, I totally missed your question. What are common phrases that indicate constant acceleration in questions, or do they say that outright? Okay, so they'll tell you that you have uniform acceleration or constant acceleration, or they'll tell you that you're on Earth. So when you're on Earth, it's assumed that you have a constant acceleration everywhere on Earth is the same, even though we know that's not true, right? Because based on elevation, you're going to have different acceleration constants, but it's going to be minimal, relative to 9.8. It should be close to 9.8. But they'll tell you uniform or constant acceleration. Those are the common phrases. Apologies, Stephanie, I totally missed it. And thank you for the person that pointed it out that did it through direct message. I appreciate that. And I was like, whoa, totally missed that question. Cool. Awesome. So now let's move on. Let's get you guys thinking. So I'm going to call these problems for thought. They're not just getting you guys thinking about typical university type questions with position versus time, velocity versus time, and acceleration versus time. So if we have a position versus time graph and we have 3 objects, 3 straight lines, 3 runners, whatever you want to call it, they all travel to roughly the same displacement. Right? Object A, object B, object C, runner A, runner B, runner C. I want to know which one has the greatest velocity and which one has the greatest acceleration. ALEP asked a really important question. Do we have to memorize the tables for sine, cosine, and tangent? Well, if you remember those full right triangles that I gave you earlier, you can do all of that. Because if you remember this triangle with 1, 2, and root 3, sine of 30 is 1/2. Cosine of 30 is root 3 over 2. Tangent of 30 is 1 over root 3 or root 3 over 3. Right? By just remembering opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So you don't need to memorize it. It does not. Typically, the MCAT doesn't ask you for tangent things. The reason being is tangent is usually used to solve for the angle, right? Because you have an x component, you have a y component. After you sum it up, you take the inverse tangent of the angle, the inverse tangent of Vy over Vx, or whatever the vectors are in terms of the y component of the vector and the x component, and you'll get the angle relative to the horizontal. That's what tangent is used for. So most of the time, the MCAT isn't asking you the direction of that vector. They only usually ask you the magnitude of that vector. Because you're not given a calculator to do that. Okay. Does that make sense? Are you ready? I'm sure like ready is your last name and V is some component of that. It's initial, but yeah. Unless you say otherwise, I'm just gonna keep calling you V ready. You can feel free to correct me. Okay, so let's go back. So out of these objects, A, B, and C, or runner A, runner B, runner C, which one has the greatest velocity? Which one has the greatest acceleration? Okay, Brooke says that velocity C. Leandro says it's A. And A for velocity seems like. What about acceleration? Leandro says it's all 0. Okay. Leandro, you care to explain your answer? I'm always going to ask you guys to back up what you did. You can speak. It's much faster, so you have to type everything out.
Sure. I'll probably sound less intelligent now, but
no. Leandro, you're going to have to speak anyway. When you get to medical school, your attending is going to ask you for your opinion every time you come up with the diagnosis, right? So why not practice now?
Sure. So yeah, I think that the slopes, I think you tried to draw exactly straight lines. So the slopes are constant, which means that the velocity is constant. So therefore 0 acceleration.
Yeah, because acceleration is defined as what? Change in velocity over change in time. Right?
Right.
So if the change is, there's no change in velocity because the velocity is constant, all accelerations are 0. So they're all the greatest and all the least at the same time. Okay, so what about velocity? Which is the greatest velocity?
If I'm still answering it, then I said A because it looked like the slope was the high, like largest, like rise over run.
Yeah, because what is the slope? The slope is giving you what? The change in displacement over the change in time, right? Didn't we define that as velocity? So the one with the steepest slope, yes. Nanika? Yeah, the one that took the least amount of time because they all have the same change in x will be the fastest. That is correct. So since they all traveled the same, right? Sure. I had a student ask, can we go over what Leandro said earlier about the slopes being constant and how that affects acceleration? So constant slopes mean what? Velocity is constant at any given time, correct? So as the slope is constant, how do we define acceleration? Change in velocity over change in time. So velocity final is the same as velocity initial because your slopes are constant. What's your acceleration? Zero. Because there's no change in velocity, right? If it was starting at 3 and it'll end at 3 because the velocity is constant. Does that make sense? So if it's constant velocity, final minus initial is always going to be 0. So therefore no acceleration. Sorry, it's much easier when you see numbers. When you see variables, you're like, they're all different things, right? Good job, Leandro. No problem. Good job, Leandro, on answering velocity. That's A. And acceleration is the same for all of them. No, I think it's good that you guys start getting used to answering because you're not going to be answering your attending with text. Right? As much as we'd like to be anonymous when we're doing diagnoses, there's no Zoom doctoring, especially when it comes to learning. All of my med students that I've gotten through, they're all like still in the field. They're doing their work every day. They're coming in. They're putting in the hours. They're still talking to their attendings every day, though with way more precautions, but still. Got to get used to talking in front of a group, even though this is all anonymous and, you know, these are still technically your peers. Cool. Any questions on this? This is just getting you guys thinking and warming your brain up again about position versus time, velocity versus time, acceleration versus time. Second question. We're still looking at displacement as a function of time. We're looking at y. It looks something like this. I want you to tell me what does velocity versus time graph look like? And acceleration versus time graph look like? Answer choices are as follows. Horizontal, constant. Negative horizontal constant. The other one's a positive one. So positive linear, negative linear. So which one is velocity versus time? Which one is acceleration versus time? Okay. Tiffany says it's D for velocity. Stephanie agrees. Iman says that it's D for acceleration. Leandro says it's C for acceleration. Tiffany says it's B for acceleration. Okay. Getting a lot of D is velocity versus time. Okay. Since Tiffany, you were the first to answer, feel free to explain your answers.
Hi, can you hear me?
Yep.
So I was just looking at the slope. So if I go to the y over x, I was just looking at slope at the initial time, so it's like high, and it like levels off. So that's why I thought would be this.
Yeah. So initially, slope, what Tiffany says, slope here is very high positive. Then it goes to 0, and then it becomes a negative, right? At this point. So it goes from positive to 0 to negative value, right? None of the other graphs do that. So yeah. Okay, cool. I haven't had anyone like cut out, Eric. Sorry. If I'm ever cutting out, let me know right away. And I'll try to reconnect to the 5G. I think I'm on the 5G, but I should be okay. So correct, Tiffany. The velocity versus time is that. Good. Thanks, Mo. So Tiffany is correct. That's answer choice D. So what about acceleration versus time, Tiffany?
Yeah, so I made an assumption here where I was just imagining someone throwing a ball. So when I was looking at compare compare this timestamp versus this timestamp, we know that velocity has decreased, and in order for something to, decrease, then the acceleration and the velocity vector has to be opposite. So that's why I thought acceleration would be down, and then once the ball is like going down like this, and the velocity kind of speeds up again. So I'm assuming that both the velocity and acceleration vectors are on the same side. So that's how I confirmed that it will be negative. So that's why it would be B instead of A.
Correct. So answer choice B, this is your acceleration vector because you have a negative number. Or if you think about it, the slope of this line is also a negative slope, right? Which is simply your acceleration, the change in velocity over the change in time that you chose. And what Tiffany did was really good is by looking at these graphs, you should try to find a physical example that fits it. And her example of throwing a ball straight up and then having it come back down to the same height, right? It's something that you do if you play basketball, right? Where you just throw it up in the air, straight up, trying to spin it, shoot it, and then you catch it as it comes back down. You see Steph do it all the time. Sorry, I'm a huge Warriors fan because I'm from the Bay Area. But you see Steph Curry do it all the time during practices, where he throws it up really high in the air and then he just ends up catching it too. Builds forearm strength and allows you to shoot for those long threes. Sure. So if you think about it, Michaela and Stephanie, you start off with a high velocity, correct? But that velocity goes to 0. So what type of acceleration do you need to have that velocity come to 0, to come to a stop? Positive or negative? Negative, right? Good. We agree. So that acceleration is a negative acceleration to cause a positive velocity to come to a stop. And then from the stop position, that velocity has to become more negative, right? So acceleration, like Tiffany said, was becoming more negative. because of that negative acceleration. So acceleration was negative in the up part of the curve and on the down part of the curve as well.
But isn't it, when I look at the curve, I think it's getting negative. We have negative acceleration going up.
It's okay. I have a dog too.
And then we have it. Then it comes to that point where it's zero. Velocity is zero at the top. But then we have gravity, so it seems like acceleration positive. It's going in a negative direction, but it's increasing.
Yeah, so down was always negative, right? In what direction does acceleration act in gravity? Down. So you just use gravity as an example, and that's the exact thing that I was actually getting at. This example of an object being thrown straight up, having a constant acceleration act on it, a constant negative acceleration act on it, is that gravity that you're talking about. So gravity does act on it. It causes it to come to a stop, and then it gets you to go backwards, right? If you were in a car, you would be slowing down as you move forward and then reversing, right? And getting faster and faster as you reverse, which means acceleration was always acting in the reverse direction the whole time, or in this case, down, since it's in the y direction.
Okay, and that's how come in graph D, the slope is going down the entire time.
Correct. In graph D, velocity is shrinking the whole time, right? It's getting less and less and less, and then it becomes more and more and more negative.
Okay, thanks.
Because if you think about it, this is zero slope. This is some slope that's negative, then it gets faster, then it gets faster at each step along the way, right? As this gets more and more steep. Whoops, sorry. I didn't mean to delete that whole curve. Yes, you can have positive velocity but negative acceleration, right? If you take a ball and you throw it up, your velocity is positive, correct? But during the whole flight of the ball, Michaela, isn't gravity acting on it, which is a negative acceleration? Good. Got it. Good job, good job, good job. Mo. I think the dog is more like, who's that person and what's that voice, more than, he doesn't like physics. Interesting. Okay, cool. Let's take a look at a next problem. Still problems for thought, getting you guys thinking about your typical university type questions. So the third question, instead of a position versus time graph, I'm going to give you a velocity versus time graph, and it looks like so. Looks like a trapezoid. Okay. So this part, it's constant, so it's staying the same value in that section. So I want to know, what does acceleration versus time graph look like? And what does position versus time graph look like? So answer choice A, something, acceleration or position as a function of time. Looks like a sine function. B, acceleration is a function of time. Looks like the same graph. C, acceleration is a function of time. Constant, goes to 0, then becomes negative. And D, acceleration or position as a function of time is curved, linear, and then concave down. Okay, since Mo, since you were the first, explain why C is acceleration versus time.
You can tell from the graph that the velocity is has a constant slope,
Mhm.
and then the velocity becomes constant, so that's zero acceleration. And then you have a constant slope downwards for the latter end of that graph.
Yeah, positive slope, negative slope, right? So here's your positive, here's your negative value, and then this was 0, right? No slope. Good. Acceleration versus time. It's answer choice C. Very well, good. What about position versus time? Don't think anyone answered that yet.
I mean, I can go. I said B.
Oh, why B? Why is it the same?
Constant distance, and then I guess constant distance going up, and then constant. I guess it might be wrong. Not too sure about B.
Okay. Let me see who else had it. Stephanie. You had another answer for position versus time.
I was just trying to think if I took the slope at various points on D, it should be increasing. Like if I took the slope at the very bottom of the graph versus at the first curve, I'm increasing, but then at some point my slope is going to be constant, which means I'm plateauing on the velocity graph. And then I think my slope starts to flatten out or get closer to 0, which brings me down. If that made any sense.
That makes perfect sense, right? Like I was trying to trace what you were actually denoting, right, on the graph D.
Yeah.
So what Stephanie was saying is that if we look at the slope, it starts at 0, then it increases at any given point, then it's linear at this middle section, and then the slope decreases until it gets to 0. Area under the curve is relevant, and this area under the curve is always positive, correct? Which is why the graph should never come back on itself. So right here, when it went back to 0 for position, if this was position versus time, if your velocity, if you're always driving forward, do you ever go back to where you started? Nope. So this is where these graphs would have failed that, right? These can't be position versus time graphs. But this one can be a position versus time graph because it keeps on getting further and further from the origin. It doesn't go back on itself, right? So these are all no-nos, right? Going back meant that velocity had to be negative at some point in order for your position graph to go back. This velocity is always positive. That's another way of looking at this too. But yes, Stephanie did a really good explanation on how the slopes of this position versus time was increasing, then constant, and then decreasing to go to 0. Does that make sense? Okay. Awesome. So now let's take a look at an MCAT style question. So now that we've done enough of these, we can actually look at an MCAT style question that they would give you. So, fourth question of the day. No, the handout you can do on your own after class is done, or you can do it and then we can go over it during office hours, but not going to do the handout today. I will be incorporating the handout when I do my GChem lectures, not so much for physics lectures. I like doing my own questions to teach you guys from, and then we'll incorporate those questions when if you have any questions during office hours. Okay. So let's say we have a position versus time graph. That looks like so. Points of interest are A, B, C, and D. Okay. All of the following are true except 1. Speed is constant from A to B. 2. The object is moving in opposite directions at A and C. 3. Yeah, give me a second. I kind of deleted it. I was running out of pages on the whiteboard and to make an executive decision. Speed at C is less than speed at D. 4. Speed at B is equal to 0. So answer choices are as follows. A, 1, 3, 4. B, 1, 3. C, 2, 3. D, 1 only. So all the following are true except speed is constant from A to B. Object is moving in opposite directions at A and C. Speed at C is less than speed at D. Speed at B is equal to 0.
You said X is displacement, right?
Yep. So all the following are true except. Answer choice A is 1, 3, and 4. Answer choice B is 1 and 3. Answer choice C is 2 and 3. And answer choice D is 1 only. And the last one here is 4. IV. speed at D. Sorry about that. Okay, let's take a look. Are we looking for true or false statements? Good. Everyone agrees we're in true except, right? So we're looking for false statements. Let's go through it. Speed is constant from A to B. Is that a true statement or false statement? Good. Everyone's in agreement that that is a false statement, right? It's going from some positive value here to 0, right? It's constantly decreasing. There's some constant to it, but it's definitely not constant. Cool. Object is moving in opposite directions at A and C. Cool. Everyone says that's true. One's positive velocity and this is negative velocity, right? The slope is positive, slope is negative. So true. So forward and reverse, respectively. So this is a true statement. Speed at C is less than speed at D. Is that a true or false statement? Is a false statement. Speed is what? We're only looking at the magnitude. So one has magnitude, one has no magnitude, right? So this is a false statement. If I had said velocity at C is less than velocity at D, then that would have been a true statement. Right? Negative velocity is less than 0 velocity. This is where that vocabulary that we talked about, noticing the difference between a scalar quantity and a vector quantity and knowing what it is. Speed is absolute value of velocity. It only cares about the magnitude. There's no direction associated with it. Without direction, you can't be negative. Right? Remember, speed tells you how big something is. No, anytime you're taking a look at, so at 2 questions come in, so speed can't be negative. No, any scalar quantity is always a positive number, typically. Is speed the only one that cannot be negative? No, distance can't be negative either. There's no such thing as negative distance, right? So anything that you have as a scalar quantity, it's always the absolute value of the vector quantity, right? Which means it can't be negative because we only care about how big it is, right? Hence the definition of scalars. Correct. Negative distance is actually positive distance, but in the reverse direction or opposite direction to what we defined as positive. Correct, Michaela. Speed of C is greater than speed of D, not the other case around. Velocity at C, though, is less than velocity at D. That's a true statement, okay? No, negative acceleration. It's decreasing velocity. Decreasing is different than negative. So velocity takes into account the direction a lot. So at C, you have a negative velocity, right? So a negative number is less than 0, correct? There we go. Speed at B is equal to 0. Oh, more questions. Is C to D also decreasing acceleration? You're negative, but then you're slowing down to come to a stop. Yes, it's also decreasing acceleration or decreasing velocity in the negative sense. Correct. You got it. Doesn't it feel great? Physics is making sense. That's what I want you guys to walk away from here. Physics makes sense. Use physics in the world. It'll make sense of how the world operates and how things function around you. Not if you apply it every day. Right? If you apply it every day to your everyday life, physics makes perfect sense, right? So think of that ball example instead of like you riding in an elevator going up and down, right? So final answer is B, because this is also a true statement. Speed at B is equal to 0. So the false statements are 1 and 3. So B is the correct answer. Okay. Let's go. We have one more question that I like to ask you. This is a real MCAT type question. This shows up quite often. So we have an object that's on an inclined plane. Assume that it stays on the inclined plane throughout the whole time it's on this curve that we're going to be drawing. Initial velocity for it is 0, and we let it go, right? Its displacement is along this direction. So I want to know, how does velocity relate to the change in displacement, or roughly to the change to displacement? Acceleration, velocity is a function of displacement, is linear. B, velocity is a function of displacement, is a negative linear. C, velocity is a function of displacement, is limiting. D, velocity is a function of displacement, is parabolic. So this is an MCAT style question. The reason for this type of question, if you think about it, if you've ever read any research papers, do you remember if you actually did the research, you took every criteria that you measured and you graphed it against itself, right? And then you're like, what does this graph actually mean? If you've done research and you've written a paper, you've done that, and you're probably going like, is this even meaningful? Right? But you have to take a look and see if you can understand what each graph is actually trying to tell you. And is it right? And is it how the world behaves? So it's assuming that it stays on the incline the whole time. How does velocity change with respect to displacement? So I like this question. Wide variety of answers. We had D, A, B, D, D. Yeah. All right. Let's start from the top. Iman, do you want to explain your answer choice B and why?
Sure. So if we look at this, it's a ball on a hill. The ball is subject to gravity, which is a constant acceleration,
That
negative
is correct.
10 meters per second. So if we imagine an acceleration graph, it's a flat line, positive. Well, gravity is negative, so negative 10 meters a second. So it's a negative flat line. And so we'd be looking at the what we want is a velocity curve. So we have to find the antiderivative, and so we care about the area under the curve rather than the slope of the curve.
But
So
when you do that area under the curve, isn't it with respect to time?
with respect to
Time.
yeah, I think it is, right?
But this is with respect to X.
Oh, okay. With relation
So
to
think about it.
okay, then I may have gotten this wrong. Yeah.
Nope. Just keep on thinking. I want to keep on thinking. Like, this is one of those problems that I want a lot of people to think. As you can see, everyone's like choosing every letter. So it's not like every one answer is correct or the other. I just want you to understand why an answer is the right answer as opposed to like what everyone's thinking. So Iman went first. Mo, you want to go? Why D?
We're assuming the incline goes on forever, then we can assume velocity increases forever. So as X increases, as we displace the ball further, velocity is going to keep increasing because it's subject to gravity.
Yeah, we never reached the end. Okay. Okay, so Michaela, you want to give why A is the correct answer?
I said A was the correct answer because velocity is increasing as displacement is increasing as well, and A seems to be the only graph that's the case.
Okay.
Like, consistently.
Okay. Sounds good. So
Actually, A makes more sense. A makes more sense.
Okay. Ria, you have the same reasoning? Okay. Iman, you change your answer. C? I wish we had a poll. If I could do a poll, it'd be awesome. Like, I want to see percentages of like how many people are choosing what. So, why C, Iman?
I think that's actually wrong. Sorry. I didn't mean C. I think thinking about this a little further, because the answers provided are not in time. They're in position. Velocity over position. So velocity over position, because velocity is position over time. Position over time over position is the same as position times position over time. So I'm trying to figure out what that means. Let's see. Yeah, I'm not sure. I'm confused.
Okay, let's take a look. I just want to see everyone's answer choices and reasoning. Oh, Ria, changing your mind? From answer choice A? Okay, so let's go over all the ones that you guys chose. I know. I'm gonna show you. So I'm gonna pretend I know no physics, okay? But I know how the world works, right? So let's look at A. Well, first of all, we start at 0 velocity. Someone pointed it out. Shouldn't it start at 0 velocity? Yes. So B's gone. So let's look at A. Let's look at D. Then look at C. Okay, because that's the order of like. A lot of people chose A, some number of people chose C, D, and then like very few people, 1 or 2 chose C. So let's take a look. So let's go from 0 to 10. I travel the same change in displacement. 10 to 20. I travel the same change in displacement. Is that how the world works? The faster you go, the more you stay the same in terms of movement. Let's take a look at answer D. 0 to 10. That's a big change in displacement. 10 to 20. Is that how the world works? The faster I move, the less displacement I have? 20 to 30. Whoa, that's even less. This is your displacement change, right? Is that how the world works? The faster you move? No, it makes perfect sense. And I'm going to show you why. Because you guys didn't use your equations. We'll look at it in a second. This graph, 0 to 10. Yeah, you travel small displacement. 10 to 20. Larger displacement. 20 to 30. Look at that. It's going to be a larger displacement. It's going to come reach somewhere over there. That's how the world works. Let's take a look why. So displacement was what? 1/2 times acceleration times time squared. Velocity was what? Acceleration times time, because v initial is 0, right? This is the question that gets you from getting that perfect, right? These are the questions that the MCAT likes to throw at you, right? The reason being, if you think about it, data is being presented in so many ways now, especially when it comes to research. When you have a scientific paper that's published, they'll present things that are not typical on how you guys learned it, right? And so you have to take your knowledge and try to make sense of what they're giving you, okay? It is constant, but what's not constant here? Time, right? When this is 1, let's say acceleration is 1. Let's say for simplicity purposes, we know it's not, right? Acceleration here is g sine of the angle, right? That's theta. We'll get into how that's the case next week when we break vectors into components, especially for forces. So if this is 3, this is 9. If this is 4, this is 16. Do you see how it keeps on increasing more towards the x and less towards the y component, or the v component in this case? The other equation that would have made it real simple for you that relates velocity with acceleration is v final squared is equal to v initial squared, which we know is 0, plus 2 times acceleration times the change in displacement. So v is equal to the square root, or proportional to the square root of the change in displacement. Which one of these graphs looks like a square root graph? C. So I showed you using common sense, looking at if we increase velocity, it doesn't really plateau. So one of the students says that, explain why the plateau of C again. Square root graphs just keep on going and increasing very marginally, right? Because you think about it, what's the square root of 1,000. That's 10 root 10. So that's like 330 something, right? Square root of 100 was 10, right? So it's just going to be a marginal y increase for the amount of horizontal increase that you get. The horizontal would have been 1,000 to 100, and the other one would have been 30 to 10. So it doesn't plateau. It just it looks like it plateaus because it increases so minimally in the y direction, or in this case, the v direction. Does that make sense? Yes.
I've seen these in the books as well. Like for C and D, when it like levels off to an axis, what is that like? Without like thinking too much about it, what does that mean? Does that mean like that axis is the one that like?
It's increasing that axis way more, right? So when v increases by 1, like from 3 to 4 to 5, x is increasing by 25, 16, 9, 16, 25. So x is increasing more horizontally than in the y vertically. I'm giving you practical numbers here of x versus v, given time being 3, 4, 5 seconds.
Okay.
Does that make sense?
So the x, so for answer choice C, like the x-axis, that's like the exponential.
Yeah, so is this not an exponential? Is this not a linear?
Okay.
Right? Because time is increasing exponentially, velocity, time is increasing linearly proportional to it. So the longer you go, the more position or displacement you're going to have because of that increased velocity. And it's the combination of these two that leads you to this equation, right? Or this relationship here. Because time is the common factor between velocity and displacement. Or you could use your fourth kinematic equation. This was using the first and the third, and the other one was using the graph, was just using logic. Okay? Does that
how is velocity constant? Does it reach a constant value at some point?
Nope, it continually increases. It just increases less than displacement.
As answer choice C is like that. It's
continually increasing, right? What does the square root graph look like? If you graph y is equal to square root of x, right? If I did x as a function of y, square root of 100 is 10, right? Square root of 1,000, like I said, was 10 root 10, which is approximately 30 something, like 33. So your y is increasing much slower than your x.
gotcha.
Does that make sense? So it's
It
still
makes sense.
increasing, it's just not increasing as much. So that's why the graph skews. So if you think of this as your midline of, y is equal to x, this is going to skew towards the x direction and not the y direction. In this case, it was v and x, right? Respectively. Does that make sense?
It does, yeah. It's just hard to visualize.
Mm-hmm. Yeah, when you put in numbers, then it makes a lot more sense, right? Yeah, so v never like stops increasing. It's still increasing like you think linearly because of that constant acceleration. So when you guys said stuff, it was correct. I said, yep, that's correct. That's correct, right? You were still using the correct sentiments. There was a constant acceleration. That's what Iman said, that time was still moving on, so that velocity is increasing, and so is displacement. You just never said that displacement is increasing exponentially versus a linear increase for velocity. Okay. All right. Let's now go and talk about 1D linear motion, and then we'll talk about 2D collinear motion. So 1D linear motion. So it's usually an object shot horizontally or an object let to fall, a free fall, right? If we're letting things fall, we know that gravity is 9.81 meters per second squared and it's pointing down, or negative 9.81 meters per second squared. Most of the time, you're going to approximate it to be around 10 meters per second squared. Okay. So let's give you a typical free fall problem, and then I'll give you the methodology and how to approach these types of 1D linear motion problems. So let's say you're at a clock tower and you're standing in the observation deck. They have bars there, so no one can jump, right? Because it's physics. So initial velocity when we're taking an object before we let it go is 0. We're gonna drop it. We want to find the final velocity just before it hits the ground, given that you know that the height of this tower is some height h. So find me that final velocity just before it hits the ground. Do it symbolically. I don't need numbers. We can always add numbers at the end. And then we can practice our mental math. But it's much easier, right? It's easier to write g than it is to write 10 or 9.81. It's easier to write h instead of like 102 meters. So write the variables only. It might be difficult for some of you, but it's always good. Negative g? I always write g and I always think of it as going down. So if it's in the same direction as g, then it's going down. I personally like making g positive unless I'm doing a kinematics equation where a ball is being thrown up or something has some initial y velocity. If an object is being shot downwards or thrown downwards, I consider just going down as the positive direction and I just go with it. Do we know time? V final. Final velocity just before it hits the ground. That's what we're looking for. No problem. Okay. They also give you initial velocity and you're assuming acceleration to be gravity. For those who are answering through private message, yeah, I've been replying back. So far, most people who have answered privately have been correct. I don't know why you don't share it with everyone else. Okay, so let's take a look at how to do these types of problems. Okay, when I call this my guess method. So I always write down what's given. So what are my givens? I know my delta y is some height h. I know my v initial in the y direction is 0 meters per second. I know my acceleration is gravity, right? Or negative g. This is negative h, right? Because you're going from top to bottom. Final 0, 0 minus the top, which is h. That's all we know, right? Those are our givens. Let's look down at our unknowns. That's final velocity. Let's find an equation or equations that can solve this. Preferably one, because you're always on a time limit with regards to physics. So which equation should we use? Seems like most of you got the right equation. Final velocity in the y direction squared is equal to initial velocity in the y direction plus 2 times acceleration in the y times the change in y, right? The fourth kinematic equation. Then we substitute. V final y is what we're looking for. The initial y is 0 plus 2 times negative g times negative h, right? Then we solve. V final y is the square root of 2gh, right? So whenever students ask me what I do, I tell them I guess. Except my guessing, I'm actually not guessing. I give my givens, my unknowns, because h final, d final is 0, d initial is h. So delta d or delta y is d final minus d initial, right? So then that negative h. Always good to ask. Cool. Yeah, because look at where you start and look at where you end, Noah. You start at the top and you end at the bottom. The bottom is 0. Yeah, delta S was displacement, remember? In this case, we're basically using like scalar quantities, right? Because we're assuming that they're in one direction. So you have to do it for the x and y direction if you have a 2D collinear motion. Yes, g is negative because it's going down. We're good? Okay, now let's do 2D collinear motion, or otherwise known as projectile motion. Commonly referred to as projectile motion. Sure, no problem. I can totally go back one. So guess method is givens, unknowns, equation, substitute, and solve. So 2D collinear motion, otherwise known as projectile motion. These are those types of problems that an object is shot, thrown at some 2D direction. So we'll use a cannonball, could have been a football, could have been whatever for their shooting. And it travels in a nice parabolic arc. Okay. Let's do that properly so it fits all on this page. Cool. So assuming the height of it is negligible, we start with some velocity, and it makes an angle to the horizontal of theta. We know that we can break that velocity vector in an x component and a y component respectively. Okay. At the top, this is commonly referred to as the apex. I want you to find me the acceleration in the y direction at the top. Velocity in the y direction at the top, velocity in the x direction at the top, acceleration in the y direction at the top, time to reach the apex, and the height that we're at the top. Yeah, we're assuming the cannonball's height is negligible, so it's starting at y is equal to 0. So you can break this down. This is v sine. This is v cosine of the angle. Also at the end, I want to find the velocity in the y direction at the end and velocity in the x direction at the end. And time in the air here is simply 2 times the time it takes to get to the top. Because whatever time it took to get to the top is going to equal the same amount of time that it takes to get to the bottom if it's shot on level ground. So determine to me the initial velocity, the velocity in the y at the top, velocity in the x at the top, acceleration in the y at the top, time to take to get there, and the height respectively. And then find me the final velocity just before it hits the ground, assuming the height of the cannonball and the cannon to be negligible. No, everything's in terms of variables. So the angle is theta. So everything should be symbolic. The reason I ask you guys to solve things symbolically, because when they do quantitative questions, they'll change things. But if you have the general equation, you can just easily plug numbers in. Whereas if you do it with numbers, then you're going to have to go back and look at what the equation was through all that mess of number calculations that you had written out. Hence why I always ask you guys to do things symbolically. Okay. In the interest of time, let's go through this. What's the velocity in the y direction at the top? Actually, let's start with the x first. What's the velocity? Yeah, Kimberly's correct. It's 0 at the top. What's the velocity of the x at the top? Very good. Zoe's correct. It's the same as what we started with, and it's always going to be the same as what we started with throughout the whole problem, because there's only one acceleration here on Earth. What is that? Gravity. And it's in the y direction. Correct, Brooke. And so since it's that case, the velocity in the x direction remains untouched, right? It's constant or uniform. There's no acceleration taking away from it or adding to it, right? So that's why, if you think about it, 2D collinear problems are just simply 1D linear problems in disguise, right? Because everything in the x direction still remains the same. It's in the y direction that it's increasing or decreasing, right? Decreasing, then increasing in the negative direction. Does that make sense? So acceleration we know is negative g. So how long does it take to get to the apex? So I had a question. Is it theta for Vy or 0? I'm confused at that question. Theta is an angle. Vy is the vertical component of velocity.
I think it's just because it looks like a theta, but I think you meant to draw a 0 where it says Vy.
Oh yeah, Vy is 0. Sorry. It was 0. I apologize. My bad. It is V sine theta for the vertical component. This is the horizontal. I had a student ask, is it not V sine theta for the vertical component? And I was like, yes. Correct, Noah. All horizontal values are constant for all types of 2D motion, unless you have air resistance, in which case you do not have for the MCAT. No, in terms of going over time, I'm trying to speed this up. We'll be done in like another 5 minutes. Okay. So to find that time, we have final velocity in the y, we have initial velocity in the y, plus acceleration in the y times time. So this is 0, this is v sine of theta, and this is negative gt. So t is simply v sine of theta all over g. And in terms of height, we're doing v final squared in the y is equal to v initial squared in the y plus 2 times negative g times your height. This is 0 at the top. This is v sine theta squared. So v sine theta quantity squared. And it's minus because you're bringing it to the other side, divided by negative 2g is equal to h. So the two negatives cancel out, and that's the height that we get. We're using our fourth kinematic equation, right? And then this one, we're using our third kinematic equation. Good grief. Okay. And to find the final y velocity, it's going to be the same except in the opposite direction. So negative v sine theta. The last thing that we need to know is to find the horizontal distance this object covers, and that's called the range. So if you think about it, range is the horizontal displacement, which is x. And since there's no acceleration in the x direction, it's the initial velocity in the x direction times time that we spent in the air. We know t air is 2 times t apex. So we can substitute that in. I'm just going to substitute it in. So we have v cosine of theta, that's your vx, times t air, which is 2 v sine of theta all over g. The 2 being this 2 right here. Is that ta comma x that you're writing? This is the range. This is velocity in the x direction, right? X is equal to v initial t plus 1/2 a t squared, but a in the x direction is 0. So this is the time in the air. Is that what the clarification was? Air. Sorry. It's air. It's time in the air. I had to write it small here. T air is equal to that. 2t apex. So that's our range, which is horizontal distance that we have covered. The reason they love asking you range questions, if you haven't noticed, this is your v naught x and this is your v naught y. Your v initial y and v initial x. Yeah, you can simplify that, Michaela. I like this equation better because it works for any system. So if we simplify it, right, you get v squared 2 sine theta cosine theta all over g. 2 sine theta cosine theta is what? Sine of 2 theta, right? The double angle formula. So in your textbook, range is written as v squared sine of 2 theta, the double angle formula all over g. I personally don't like this equation, though it's in every physics textbook ever written. I personally like this equation because it's much simpler, right? But if you know where the components come from, it's technically the same thing. And by writing it this way, you clearly see the x component, you clearly see the y component, and how they interact together. When you write it this way, it doesn't show any of that because they've already combined it in the sine of 2 theta. Does that make sense? Okay, so with that, we're done with translational motion. If you have any questions, feel free to email me, khoin79@yahoo.com. And I will see you guys on Wednesday at 2, same place, same bat channel, same password and meeting room ID.
I have a quick question.
Yeah, I'm going to be around for questions until 4:30. If you have any questions, feel free to stay and ask.
Okay, don't delete the screen yet then.
I'm not.
Okay.
Go ahead.
Okay, so just I was writing, and I think I missed this, down in on the lower right side where we're looking at the final v final
Y
and the y in the x direction. Does that say equals 2 times minus v sine?
No. There was a question mark there. I should have deleted the question mark. The vx final is still just v cosine theta. So it stays the same here, here, and here. And then in the y direction, it's just negative v sine theta. I want to delete the question mark. Yes, thank you guys.
And
Have a
then
good
just
day.
quick question about the angle, because I think I think I'm a little bit confused about the angle. So when we're looking at V sine theta and V cosine theta, depending on how you draw the triangles, like what does your triangle look like on the right? On the lower right for the,
It could be any angle, right? That's the whole point. That's the beauty of this, like leaving it as a variable. It
Mhm.
could have been this type of triangle that you had, or it could have been this type of triangle that you had. Right? But oh, you mean on the lower right? It'll be the same except inverted. It'll look like this, and then like that, and it'll look like that. I'll draw it in red so it's easier to see.
So the angle is always the angle from the x-axis up.
Correct. And so that angle will be this angle roughly.
Okay, and I think in class, what we were taught was that when we did this calculation, we were looking, and I don't know if I can do markup, but like if we, I don't think I have that button, but the angle would be where you drew theta, like so let's say that's 30 degrees, or well, it's actually closer to 45. So
Sure.
if that's 45 degrees, then the angle that we were calculating would have been 180 degrees minus 45. Like it would have been that, what do you call it? The angle on the other side.
Oh, you're talking about this, like if you're taking it as a horizontal from, I know what you're trying to say. So you're saying if it was, this was, oh God, why do I want to erase? This was the horizontal, you're talking about this, the whole thing like that? Or are you taking this angle right here?
Yes,
This
that angle,
so-
right. Yeah, except on the opposite side of theta. Like if theta is 45.
These would be alternate interior angles, so they'll be the same.
But that we'd be calculating when we did the V sine theta or V cosine theta, we'd be calculating the angle.
You would have just calculated with the inverse tangent of whatever the y component was over the x component, right? This is how you did it in normal physics class, no?
Right, that's right, yeah.
This is how you calculated theta, and it would have been relative to Vy over Vx, which is why this angle here is still there.
So when we're doing that arctan calculation, are we calculating theta, or are we calculating 360 minus theta or 180 minus theta?
So arctangent is only real between negative 90 and positive 90. So you're going to be finding an angle relative between from the fourth quadrant and the first quadrant when you're doing it for class. You're not going to be doing calculation for the MCAT.
Okay. All right, thanks.
Oh, that's a trig identity? Someone asked me, like, when I circled 2 sine theta, cosine theta, and wrote sine of 2 theta, that's a trig identity. If you go back and look at your trig identities, that's a double angle formula. And they're equal to each other. So you get this equation from that. 2 sine theta, cosine theta. No, you don't need to know any arcs. You just have to know those helpful right triangles. So if you know your sides are 1/2, then you know the angles. If you're looking for the sine of it, then it's one that's 30 degrees.
I had questions on the examples.
Sure.
So for like
Which
number
one?
2,
Yep, we're here.
yeah, I'm not understanding why acceleration is negative.
So how do we define acceleration? Change in velocity over change in time. If we know that this is our velocity graph, isn't that just the slope of the velocity graph?
Oh, okay, makes sense.
Right?
Right.
Slope here is a negative number, right? So here's our negative constant. This is a negative number right here because this is 0, right? The time axis represents 0 on the y.
Okay. And then like rapid fire, could we do 3 and 4 also?
Sure. I might have deleted 3. Sorry. 4, because I knew that I had to like skip one page, but I chose to delete that one. I thought the notes might be something someone wanted to refer to back to.
I mean, if you can remember 3, we said that you said the distance keeps on going. Why
Yeah,
is
so
that? Why is
look
that
at-
so?
Let me find something I can delete. Vocab. Let's delete that. No one needs vocab, right? Okay, so let's go back and look at 3. So if you think about it, here's the problem, right? We had a graph of velocity versus time that looks like this. Right?
Yep.
And I was telling you that the position versus time graph.
Yep.
Looks like this. Correct?
Yes.
Okay, so is velocity ever positive? I mean negative
It can be.
in this graph?
Oh, yes, towards the end.
This is negative? Sorry. Dang it. I hate it when I have it on erase. Where does it turn negative?
When it's coming back down to 0.
It's decreasing, but it's never negative. You're slowing down, but you never turn around. You have to, there's a difference.
Yeah, that was another question. What is negative velocity? Like, I don't.
Negative velocity is whenever it goes underneath the t-axis, right, into negative land. This is
Okay.
negative, this is positive, right?
Right.
So velocity is never negative if it doesn't cross below the x-axis, right? Or in this
Yes.
case, the time axis.
Right.
So velocity decreasing is different than negative velocity.
Okay.
Okay?
Yep.
So velocity, is it ever negative?
In this case, no.
In this case, no. And if it's not negative, do you ever go in reverse?
No.
No. So this is why all the other graphs, was it answer choice A was
Yeah. I
come
don't know.
back on itself, right? Answer choice C comes back on itself. And answer choice D, what was answer choice? That was answer choice D. I think B was the same graph and it comes back on itself right here. Begins to come back right there. I circled all the points where it begins to go backwards.
Okay.
So if
Yeah.
velocity is always positive, okay, so let's say, sorry, what's your name? Do you feel comfortable me calling you V Ready? Is that your name?
It's Vinay.
Vinay. See, that's what I
Yes.
figured, right? That's not, I was like, Ready's your last name. So Vinay. So if we're looking at it, velocity is positive, that means you're going forward, right?
Yes.
If you're always going forward, what happens to position? It's always going to be increasing, right?
Yes.
What happens here at this point, and this point? Displacement would be decreasing,
Right.
right? Or you're going reverse,
Right.
correct?
Okay.
So that's what I was trying to get at.
Right. Okay. Yeah, and that answers number 4. I was just wondering why positive and negative velocities opposite directions, but I just
Yeah. So with number
Yeah.
4, right? Positive means
A
you're
and
moving
C.
forward. Negative means that you're reversing, right?
Right.
Yeah, at A and C.
Okay. Yeah. That's all I got. Thanks.
Cool. Yeah. No problem. I think there was a question that came up, or was it a clarification? Correct. So if you're dropping something, then it begins to accrue negative velocity because of the negative acceleration that's pulling it down. That's correct, Noah.
I also had another question.
Sure.
You still have the first example available?
Sure. First question, this one.
Yes. So I understand that I guess my question is, why is the velocity 0? Or
Why is
constant?
the velocity 0 or
Or
the acceleration 0?
the
Uh,
acceleration.
Todd likes you to do the handout a lap. Sorry. Basically, when you do phase 1. Okay, so you were saying velocity. I never said velocity 0. Where did I say velocity 0 here?
I meant to say acceleration.
Okay, cool. So acceleration is 0. Why is acceleration 0? Does the slope change for any of these curves?
No.
No. So if slope is constant, what does that mean for velocity? Velocity is constant, right?
Mm-hmm.
Because velocity was the change in displacement over the change in time. They might have different velocities, but those velocities don't change over time.
Okay.
Correct?
Yeah.
And how do we define acceleration?
It's the change in velocity over time.
Correct. So
That's
if velocity doesn't change,
same.
then you don't increase or you don't accelerate.
Gotcha.
Think of driving a car. If you're in cruise control, are you hitting the gas?
No.
You're staying the same, right?
Yeah.
There you go.
I guess it's just like confusing, like looking at the graph, because it looks like C would be the greatest acceleration.
Well, if you think about it, C traveled the same displacement in the longest amount of time, right?
Yeah.
Would that be the greatest acceleration?
No.
Yeah, would be the slowest velocity, right?
Gotcha. Okay.
Right? Let's say you're trying to run a race and you just did it in the longest amount of time compared to like runner A and runner B.
Yeah.
Right? You would be the slowest for running a race, right? That's answer choice C.
I guess
Not saying that that's you. That's saying that that's answer choice C. C would be the slowest.
Gotcha. I guess it's like trying to like break your mind habits of like constantly viewing like the furthest as like the greatest.
Okay. Yeah, because you think of this whole line being really long, and that's like the furthest displacement, but not in terms of time. It isn't. Right.
Yeah.
It just means that you traveled the longest time. It took you the longest time. Right. So that's why I wanted to go back and do the position versus time, velocity versus time, acceleration versus time, and also link it back to your current questions that you guys have in your MCAT type questions.
Thank you.
You're welcome, Michaela. Good questions. Keep them coming. Cameron,
So for
Noah?
this,
Yeah, go ahead. Noah?
just on the same question, you said that the slopes are all the same for those.
No, I said the slopes are constant for them. They're not the same.
Okay, that's
Different
that
slope.
answers my question.
Yeah, so A has the steepest, then B, then C, right?
Okay, yeah, that's what my understanding was. Just making sure.
Yeah. So this will be the slope of A, slope of B, slope of C, right? So slope of, what the heck? I was able to write a second ago. Oh, my battery for my thing just ran out. Give me a second. It's embarrassing. It charged for 2 hours. It like slope of A is greater than slope of B, which is greater than slope of C. Cool.
Okay. Yeah, thank you.
Yep. Thank you. Thanks for chiming in today. Very helpful. But it's good that you're like, it's sinking in and it's like connecting. You're making those connections. Like, I love those epiphany moments.
A real quick one. Just could you explain again why exactly you put delta S in the fourth equation? Like, what is delta S like?
It's
what's it mean as a placeholder?
Oh, I'm just using it as a change in displacement. You can use it as delta Y or delta X.
Oh, okay.
Yeah, but I'm just using it as a placeholder because I don't want to like the book says write it twice, but I'm just using a variable that you can switch X and Y in whenever you want.
Okay, thank you.
Yeah, and I just chose S because arc length, right? Because that's still displacement in a circular path.
Okay, yeah, that makes sense.
Yeah. Cool. Fabiana? Aruna? Jonathan. Jonathan was funny today. Kind of like the goofiness.
If nobody else has one, I had a real quick one, another
Sure.
one. I kind of missed when you went over the range for that very last 2D motion problem. Could you go over why that makes sense again, real quick?
Sure. So what is range? Range is just horizontal distance, right? We'll start with
Yeah.
this equation right here. Right? Displacement is equal to initial velocity times time plus 1/2 AT not AT squared, right? But acceleration in the x direction is 0. So range is just horizontal velocity times time. And that's what this
Oh,
equation
okay.
is right here, right? Horizontal velocity was v cosine of the angle. Time in the air was 2 times the time of the apex, right? And time of apex was this. So that's why it's 2v sine theta over g. Did I lose you?
Okay, because you use time of the apex.
Yeah, so because you think about it, the time that it takes to come up will be the same time it takes to come down.
Okay, yeah, that makes sense.
Gravity took this long to slow it down to 0. It's going to take gravity that long to accelerate it back up to this velocity in the y direction.
Okay, I think I understand it now.
Yeah, so that's why I doubled that time.
Okay, perfect. Thank you.
Oh. Any other questions? Good questions. Exactly. You learn the best when you look at examples and go over it, and then you also learn from a lot of people's mistakes. Jonathan, do you have any questions before I sign out? Thanks for the funny comments. Kept me laughing. Yes. All right. Have a good day. I'll see you guys on Wednesday. I'll let Josh know office hours.